Okay, class, welcome to today's lesson. Today we're going to do a little bit summarization, okay? 7.5, basically we're going to summarize all the integrate technique we learned so far. So let's recall from we learned technique will be U sub, okay, trig sub, integrate by parts, integrate trigonometry function, and integrate rational function, which is a partial fraction. So I think that's the 5 techniques we learned. So for point number 4 first, and here is the integrate trigonometry function. And you see there's a Q power. We know that when we have a Q power, we're going to break it. And break this to be sine square x sine x over cosine x, and then dx. And then when you break out, we know this is going to come as a group. Okay, and this one we continue to break it, and this one become 1 minus cosine square x. So that becomes 1 minus the cosine square x, cosine x, and then sine x dx. Now we're going to use the U sub. We know that this is the one that we the same variable. That will be my U. Okay, we're going to let U equal to cosine x, du equal to negative sine x dx. We already have a sine x dx here, so we need to take the negative to other side. So this becomes a 1 minus U squared over U, and then negative du. Put the negative outside, or you can multiply up here, so it's up to you. So negative, and then I'm going to break this into 2 parts. So 1 over U, and then minus U du. So that's equal to negative ln U to negative become plus 1/2 of U squared and plus C. And then at the end, just put the U back. Okay, U equal cosine. So ln cosine x here plus 1/2 cosine square x plus c. And you want to simplify further, you can, but if you don't, I'm okay with it. Okay, so that is how you do number 4. This one using trigonometry substitution. And let's try the 1. We're going to try to use all the technique that we learned so far. And the next one we're going to do is a number 12. And that is the integrate 2x minus 3 over x cubed plus 3x. This one is a rational function, so therefore will be integrated by partial fraction. So we're going to factor this one first. Okay, so this is going to be x and then x squared plus 3. So we're going to do the partial fraction first. So we have 2x minus 3 here, x squared plus 3, and that's equal to x here plus x squared plus 3. So this is degree 1, so that becomes on the top. Degree 2, that will be linear on the top. Okay, and LCD be right here, so this one require x squared plus 3. And this one require x. So we will have 2x minus 3 equal to ax squared plus 3a plus bx squared plus cx. And now we're going to calculate our find our ABC. Well, let's see. There's 2 of them has an x squared, so a plus b. There's no x squared here, that's b 0. Okay, so that one's gone. This one's gone. And we have one of them for x, so c is equal to 2, so that's pretty good. So these ones are gone. And the last one is 3, negative 3 equals 3a, and then a is just equal to minus 1. So that means that this one comes out is equal to -1. B is equal to, oh, I haven't get B yet. So B just equal opposite A, so equal to 1. So this becomes x plus 1. The B is equal to 1. Oh no, not s squared plus 1, s squared plus 2. So s plus 2, I'm sorry. So that is, so this becomes -1 over x plus 2 over x squared plus 3 dx. This one's easy, so that's -1 over x. This one, you're going to break it to 2 parts. So when you see like x plus something and the x squared plus something, usually that's how you do it. You're going to break it 3 and then plus 2x squared plus 3. Okay, and so I need more room here, so I'm going to erase this part. So let's do this one first. I might need more room here. So when I integrate x over x squared plus 3, so what they equal to, that these ones, when you're 1 degree lower than that, that's a u sub, okay? U is equal to x squared plus 3 du equal to x dx. Yeah, x dx here already, so I forgot to write a dx here. And then just divide by 2. So that means that this 1/2 du equal x dx. Now put it back inside. That becomes your u. S ds, I forgot a dx here, so this equal 1/2 du. And so that's equal 1/2 ln u. Okay, so this become 1/2 ln. Your u is equal to x squared plus 3. So that's for the second one. Now the last one is a tangent inverse. Okay, we did that one before. Uh, 2 over x squared plus 3. This is a dx here. Make this to be square root 3 and then square. Okay, so that put the 2 outside. So this is a 1 over square root 3 tangent x over square root 3. So that's made it to be square root 3 square, and then you can use the formula. And so your final answer, just add 2 over square root 3 tangent inverse x over square root 3 and then plus c. So your answer be all these together. Okay. So that's for point number 12. And then we're going to try another one. We're going to try point number 14. So the second problem, we use a partial fraction. Okay, the first one, we integrate 3. I try to review all those for you guys, and then there's a u sub inside also. The next point is number 14. Oh, I write too high up. Number 14. We have integrate ln 1 plus x squared dx. Well, we mentioned before in class, every time you see ln or tangent inverse or any kind of inverse function, that always be a u. Integrate by part. So this one has to be integrated by part. Okay, you cannot integrate just directly or any other method. So you're gonna so this would be formula be uv minus v du. Okay, so we're going to use this formula. So we're going to let u equal to ln 1 plus x squared, and then going to erase that. your dv just equal dx. So one's a u, one's a dx at dv. And du is equal to 1 over 1 plus x squared times 2x. Don't forget the chain rule. And then your v just equal to x. Form is a uv minus a v du. And uv is also v, I'm sorry, not v ln. I'm sorry, x. Sorry about that. 1 plus x squared minus v du. So 2x squared. And then 1 plus x squared dx. Okay. Oh, I forgot dx here. Forget dx. Now for this part, yesterday I gave you guys on last lesson 7.4. I say if they're the same degree, you're gonna use a long division first. Okay. So we're going the 2 can take out. These are 2 can take out, but these can divide. And then you can see 1 here, so that becomes x squared plus 1. And subtract it, so subtract it become negative 1. So this will become, now this is not changing, but this one, okay, become integrate 2 here, and then 1 minus 1 over 1 plus x squared. And then dx. Well, that become very easy. Integrate just equal to 2x. And then there's a negative here, so I put the negative here. Okay, so negative 2x. And then plus, there's a tangent inverse, okay, don't forget. So 2 tangent inverse x plus c. And then put back the 1 in the front. And so that's what we get. Okay, for the answer. So that's number 14. And then we're going to try another one. We're going to try one that requires trig-sub. So normally in class, if this is in class, I will have you guys to do some class exercise. But because it's not, so I'm going to just show you all different type of format, all different type of pattern. Number 16, when you go 0 to square root 2 over 2, and x squared okay. By the way, sometimes the u-sub and trig-sub can, sometimes some point can be done by both way. Okay, sometimes, and that depends on problems. So this one, I look at this. This looks faster to do it by u-sub, by trig-sub. I'm sorry, faster to do it by trig-sub because that's where a trig-sub pattern here, right? And so I'm going to go x equal to either you're going to go sine, cosine. I'm going to use a cosine because it's easier to I'm going to use a sine because it's easier to come out as a cosine. Easier to integrate that. So sine x or sine theta. Okay. And then x squared. So you note. So 1 minus sine squared theta. And I gave you guys the formula last time. I said just equal cosine theta. Okay. And then this one, and then I have a limit too. So some students said the limit is easier, so I'm going to use the limit. Okay, so when x equal to 0, and then theta also equal to 0, and when x equal to square root 2 over 2, and then theta is equal to power 4. Okay, so that's pretty easy to convert, and then so that becomes 0 power 4 x squared, that becomes sine squared theta, and the bottom is a cosine theta, and dx, take the dx here, I forgot to take the dx, so I'm going to do it right here. Dx is equal to cosine theta d theta, so this is cosine theta d theta. Well, that's pretty nice, so that goes away. Now this one, 0 to the power 4. Sine square is, remember the formula is a cosine 2 theta equal to 1 minus 2 sine squared theta. So sine squared theta will just equal to 1 minus a cosine 2 theta over 2, okay? If you don't remember the formula, you just convert like that. So I'm going to put the 1/2 in the front. So I will have 1 minus a cosine 2 theta d theta. And integrate this one, so it's equal to 1/2 theta plus minus, and therefore just divide by 2 here, so sine 2 theta, and then 0 to the power 4. And then put it inside here, so that becomes 1/2 power 4 minus 1/2 sine 2 times power 4. And then subtract this, just a 0, okay? The 0 going inside the 0. And that's equal to 1/2 power 4 minus that reduce become 2. So that is a sine power 2 is equal to 1, so 1/2 minus 1. So comes out equal to power 4 minus 1 over 4. Oh, power A, I'm sorry. Making small mistake here. So that is the answer for number 16, okay? So this one is a true sum. And you can simplify, you can use a U sub also, okay? I'm thinking about if we let U equal that, maybe we could use a U sub, but not sure, okay? So when you have time, you can try it. And the next problem, okay, we use it. And I want to do another one for number 14.2. Sometimes some problem may not able to use any of the technique we stay about. Could be combination of 2 techniques. Now the last problem, this one, sometimes we have to do combination of 2 techniques together. Or we did a couple of them earlier too. There's some use of some integrate by parts or a couple of techniques together. Number 14.2, we're going to integrate tangent inverse x over x squared dx. So when you see inverse, that's always an integrate by parts. So that's your u. So u is equal to tangent inverse x, and your dv is just equal to x negative 2 dx. I put it negative 2 so easier for me to integrate later on. And du equal to this one, derivative with tangent inverse equal to 1 over 1 plus x squared dx. Okay, this one v just equal to negative 2 plus 1 negative, so it's a negative 1 over x. And so uv minus v du, so this is 2 negative 1 over x tangent inverse x minus, well, 2 minus become plus, and x 1 plus x squared dx. Don't multiply inside because this one very likely to do it by partial fraction, okay? So we're going to break this one. So now this is already done, so I'm going to take care of this one. So 1 over x times by 1 plus x squared is equal to x 1 plus x squared, so this will be a, well this one's a quadratic, so it's a bx plus c. So I'm going to again, okay, multiply 1 plus x squared here, multiply by x, so I will have a 1 equal to a plus the ax squared plus the bx squared plus cx. And a plus b give me 0. Okay, that's very nice. C is equal to 0, there's no x here. And then a is equal to 1. So that means that this is a 1 here. I forgot to get b again. So b is equal to negative 1. So this is a negative 1. C is equal to 0. So it comes out equal to, so I have to erase this one. So the integrate becomes 1 over x plus minus this is b is equal negative 1, right? I forgot. Don't put the negative, put it right here. Okay, so negative x. And then minus x over 1 plus x squared. Okay, dx. So that will equal to, this one is just equal to ln x, and minus this is just u sub, okay, u is equal to 1 plus x squared, du equal to x dx. So your x dx just equal to 1/2 du, so this is 1/2 du over u. So just equal to ln x minus 1/2 ln u plus c. U is equal to 1 plus x squared. And you can see there's a lot of pattern here. Okay, we do this so many times. And then you add back this part. Okay, you add back, your final answer will be negative 1/2. Sorry, I have to write so small here. And then plus this big chunk. Okay, plus this part. So all these together, and that be your answer. So that's for number 42. And then sometimes some problem, it doesn't look anything at all. You know, you look at the problem, you say, whoa, what's this? How am I going to do the problems? So when you couldn't find anything, you also try to use sub first. Okay, when you couldn't find anything, any technique, then I will also try use sub. So let's look at problem number 44. They want to integrate 1 plus e to the x dx. You look at this problem, you said, wow, I don't see anything here. Well, not trig sub for sure, not partial fraction, not integrate trigonometry, and then, well, there's not integrate by parts. So there's no two function multiply here. Well, you can this one, but it's not going to help you anything. Okay, so the only way is to try to use sub. You're going to let u equal this whole thing here. And then we square on both sides. Now take the derivative on both sides. This go to 0. This will be ex dx. Well, let's see. That helps me anything? Well, looks like this will becomes u. My dx, I have to divide the ex on both sides. So become divide the ex, divide the ex. So this is u here. My dx equal to 2u du over ex. Well, you cannot integrate like this when you have x here and then you have u here, two different variables. So I'm going to solve for e. Okay, I'm going to go here. I solve for ex in terms of u. So ex equal to u squared minus 1. And then I put it right here. So that becomes 2u squared on the top. The bottom becomes u squared minus 1 du. 8, you said you can integrate this one because that is same degree here, so we can partial fraction, right? So we're going to divide it. I'm going to put a 2 outside. So u squared minus 1, so go 1. And then I subtract it, so they become 1. So this becomes 2, 1 plus 1 over u squared minus 1. That's easy, but this one need to continue, okay? 1 over plus we can do it, but minus we can go u plus 1, u minus 1. Partial fraction continue. And so that becomes, so I'm going to do right here, okay? Take away this part. So I have a u plus 1 plus a b u minus 1. And so that becomes au minus a plus a bu plus b. And this whole thing equal to 1. So we can calculate the a and b. So to save time, because they do not, YouTube won't let me stay for too long. So my a is equal to 1/2, negative 1/2, and my b is equal to 1/2. So then I will integrate this one first. So this is 2u plus a 2 times, I take out the 1/2 for both of them. Okay, this is a negative 1/2, this is a positive 1/2. I factor out the 1/2, and then all I have is 1 over u plus 1 plus 1 over u minus 1 du. And that reduce, so that become 2u plus this is ln u plus 1 plus ln u minus 1. And I just put the u inside, then I'm done. 1 plus e to the x. And if you want, you can put these together, ln multiplication. Okay. Oh, I forgot the negative sign. I forgot this is a negative 1. Sorry, negative 1 here. This is a negative. Good thing I captured it. Okay, so I can put it together. So I take this divided by that because negative is in the bottom. And then I put the u. I need more room so that my final answer comes out. It's equal to 2 1 minus e to the x plus ln 1 plus e to the x minus 1 1 plus e to the x minus plus 1, and then plus c. So that's for number 44. And the last part I want to do is number 78. Maybe I have a couple more minutes before the 30 minutes up. This one's going to be very quick. Actually, not very quick for this one. So if you're going to integrate number 78, if it's they chop me off, and I'm going to just do the part 2 then. Okay, so this one again, you know, couldn't do in other method, right? So every time you couldn't do another method, then you think about what is U sub maybe possible, but even U sub doesn't work. Then we think about maybe we can do like the conjugate. They can make it simpler. Okay, so we're going to multiply conjugate for the one in the bottom. I'm going to multiply another sine x, 1 plus sine x, and then multiply 1 minus sine x to a 1 plus sine x dx. You can see this conjugate become 1 minus a sine squared x, and that will become cosine squared x. And then these two I'm going to just multiply together, so 1 plus a 2 sine x plus a sine squared x. Okay, so that becomes 1 plus a 2 sine x plus sine squared x over cosine squared x dx. Now I'm going to break it to all 3 portions, okay? And I'm going to break this to this one. I'm going to break it to 1 minus the cosine x first. And then 1 and 1 become 2. 2 plus 2 sine x minus the cosine squared x over cosine square x dx. Then after that, I'm going to break it again to 3 portions. And so that becomes 2, and 1 over cosine square just equal what? Secant square x. We know we can integrate this one. Plus 2, this one is as a tangent secant x secant x. Okay, I just break the square break the cosine into 2 parts. The cosine times cosine. So one of the cosine with the sine become tangent, and another one is just a secant. And then subtract this one just a 1. And this just equal tangent. This is a secant. Remember, this one just comes out equal 2 secant. And then this is a minus x and plus c. Okay, so that's how you do these problems. So I will see you guys a little bit for the conference. Okay, have a good day.